All right, guys. Well, we made it to the end of Unit 6. This is our last set of notes in Unit 6. And we're going to hit up one more way that we are going to make predictions and understand things about a population based on what information and data we can pull from a sample. So, what we're going to be talking about today are called confidence intervals. And essentially, what this goes back to is this same pattern here, right? So again, we have our population, the fries. We grab a sample of fries, pull that out, and we measure those, right? Because that's the question we're asking: is the length of the fries, right? We get our data here, number 4, from the sample, and then we make predictions. Well, the question is that we've always gone back and asked ourselves is, how much trust can we put in the predictions? How accurate was this data? How good was this sample? And what a confidence interval is, a confidence interval is kind of one way to gauge how much can you trust the predictions from the the predictions from the sample going back to the population. And so what we're gonna look at specifically today is averages, is mean, and developing confidence intervals of the mean from a sample in terms of projecting that back onto a population. Now, if your confidence interval is really, really large, then that's actually a bad thing. I know we think of confidence, a large amount of confidence being good, but essentially, if we're trying to be very specific, if we're trying to know information and know things, we don't want a wide range of possible answers. We want a very small range of possible answers. So the larger the confidence interval, the actually less confidence you can have in the data from the sample being predicted back to the population. All right, so let's talk here. Inferential statistics. It's just a fancy word for describing what we're doing. We're drawing conclusions about a population using a sample. All right, some examples: the polls in a presidential election. When they say so and so is a 53% lead, if it's 53% to so and so is 47%. That's not the entire nation. That's samples from the nation that they're then projecting onto the entire nation. When you see a toy car commercial and it says miles per gallon, right? Well, that's not the miles per gallon for every single type of car, or in this case, a Toyota Camry. That's a sample of Toyota Camrys. They take the average miles per gallon from that sample and they project that out to the entire population of Toyota Camrys, right? Now, the question is, when they make that claim in the commercial that a Toyota Camry gets 36 miles per gallon, what is the confidence interval with which they're making that statement, right? So when they say 36, they don't actually mean exactly 36. They mean, well, we're going to say 36, but it could be plus or minus 4 miles per gallon, meaning that a 36 mile per gallon average could really be anywhere between 32 miles per gallon or 40 miles per gallon. All right, and so we're going to learn how do we actually calculate those intervals, those confidence intervals, the margin for error in taking something from a sample and moving it out to a population. So enough talking, let's get going here. So we're going to be working with a mean to a specific degree of certainty. Now, here's the deal. Different levels of confidence require different z-values. Notice we're still working with standard deviations. These are all, right, standard deviations, z-values. How far away from the mean are we getting? Remember, and these percentages, guys, is essentially how much of the data set is going to fall in that. So you notice the z-value for 90% is smaller than the 99%. Now, obviously, we would love to be able to use the 99% confidence interval, but if that gap is too big, then that's not something we want to work with. In order to calculate our confidence intervals, guys, we're going to need to know two things. We are going to, I'm going to get rid of that and undo that. We're going to need to use the standard deviation and the sample size. Those are going to be the two important things that we need to be able to know from a specific sample there. So the maximum error estimate, this is E, this is what's going to give us our confidence interval. This is going to be essentially our plus or minus. So the maximum difference between the estimate of the population, oh, come on, getting crazy on me here. mean and its actual value. So when we look at this formula, you're going to be given this formula on a test. So you're going to have it. So we just have to know what these mean. E is the error there. Z is our Z value. And that is going to change based on what level of confidence we're going for. Do we want to include 90% of the population, 95%, or 99%? All right, S, as you can probably guess, stands for standard deviation, and N is our sample size. Think of N as the number of people in the sample. All right, so let's go right into an example here. A poll of 218 selected members of a social networking website shows they spent an average of 14 minutes per day on the site with a standard deviation of 3.1 minutes. So this is our sample, 218. We have the mean, the average of the sample, and the standard deviation of the sample. What we want to know is what level, what confidence, how far, what's the interval if we want to expect 95% of the entire population with using this data here, right? So when we see 95%, what we're talking about is 95% of the whole population. All right, that's kind of how we want to think about that. There, that we're including 95% of the population, because that's how we get our Z value up here. Knowing that we're looking for 95 gives us our specific Z value. So at this point, guys, it's pretty much just plug and chug here, substitute and simplify. So E, our error, is going to be equal to our standard deviation, 3.1, over, as you can see there, the square root of N. So square root, in this case, of 218. Oh, and I'm sorry. Based on the formula, I should put the other value first. And the Z-score goes first. Well, a 95% confidence interval is a Z-score of 1.96. All right, so that's going to be 1.96, right, times that whole value there. And so now it's just a matter of plugging and chugging in your calculator. So let's get out your calculator, and let's do 3.1 divided by, I'm going to do it in this order, the square root of 218. And then multiply that by 1.96, and I got an E value of 0.41. That's what I got. So essentially what that's saying is we are allowed, in stating the average for a 95% confidence interval, to be 0.41 minutes off above and below the average. So what is our confidence interval here? Well, our original mean, remember, was 14 minutes here. So it's 14 plus or minus 0.41, which gives us a confidence interval of 13.59 minutes to 14.41 minutes. All right. So essentially, we can expect that for a 95% confidence, 95% of the population, based on this sample, that the mean will fall somewhere between 13.59 and 14.41. This is telling you, again, how far are you allowed to be off? How far can you expect to kind of be off taking a sample and going back to a population? All right, let's look at another one here. 184, that's our sample, randomly selected high school teachers spend an average of 16.8 hours grading, planning, and preparing for class. The standard deviation is 2.9. And now what we want, you can see here, is we want a 90% confidence interval. And that's going to change the Z value here. So again, let's find our E, let's find our error. A 90% confidence interval, you can see up here, is 1.645. So E is 1.645. Let me move that down. That's not going to be right. Times the standard deviation, which was 2.9, over the square root of the total number of people in the sample there. So 1.645 times, in parentheses, 2.9 divided by the square root of 184. 184 and equals 3.35 is what I got here. 0.35. So again, what is that saying? That's saying that our average, which was 16.8 in the sample, we can expect an error, a margin for error of 0.35 above and below when we are projecting that sample back onto the entire population here. So 16, what are we going to have here? We're going to have 16.45, was it hours? Hours to 17.15 hours. All right. So again, we would have a 90% confidence that taking this mean from the sample, the 16.8, and projecting it onto the population, that the actual mean would fall somewhere between this range. And here's the one catch, guys. There's absolutely no way for us to know what the actual mean for the entire population is, unless we're literally going to be able to find and survey and get data from every single person. So what we're doing with these two confidence intervals is we are making a prediction about a number that we can't possibly know. It's kind of crazy when you think about it. But that's why we need this window. That's why we need this intervals, because we can't know the exact value of the entire population. We can just make our best prediction based off of what we know from the sample. All right. That's kind of what we talked about here. I think I kind of jumped ahead there in example 1 and 2. I think I did what we were doing there all down here. So there's one more example that I want you to try here on your own, and this is talking about a 99% confidence interval. And one thing, guys, too, is that we always want the 99% confidence interval. That would be the ideal thing. We want to be able to include as many people from the population as possible in our estimations. That would give us the most certainty in our predictions. But if the window, if the interval for a 99% confidence interval is too big, then it's not useful information to use in a prediction, and we have to lower our expectations for our confidence to get a number that's manageable there. And we'll see more of that when you get to the worksheets and the study guide. All right. So again, try this problem on your own. Check real-time board to see what you get here. Hopefully you can come up with the correct confidence interval for a 99% situation that we're looking at here. Again, as always, any questions, shoot me an email, ask on ClassKick, ask on Schoology. Please reach out, try the worksheet, practice it, try the formative assessment so we can really kind of get a sense of where we're at before we head into the test here, Unit 6, Part 2. Well, that's all we got. End of Unit 6. Good job. And we'll see you next week when we start reviewing for the test.